The company that built the world's most sophisticated AI coding tool just leaked its entire source code because they forgot one line in a config file. 1884 TypeScript files, every system prompt, every unreleased model name, all of it publicly available to anyone who installed the npm package. When you publish a package to npm, which is basically the app store for JavaScript code, there's a file called .npm ignore that tells the system which files to leave out. Anthropic forgot to exclude their source map file, and that single oversight exposed everything. I went through all of it, obviously using Claude Code itself. Let me show you what's inside. Basically, this is a package that is present on npm, and they forgot to add a configuration to the ignore configuration, and so you could actually reconstruct everything. This is a repository that this is not the original, very original repository. This guy here, he rewrote, maybe probably because of legal implications, into his own version of Claude Code. Basically, he has the code and he's rewriting it using a different language called Rust, but it's practically the same thing. And it's a, claiming that the fastest repo in history to surpass 100K stars probably happened in like a few hours. And he explains the backstory here at 4 a.m. on March 31st, which is just 2 days ago. I woke up to for my phone blowing up with notifications. The Claw code. He has even changed the name because of legal implications. So Claw means cloud code here. Someone else has the repo still available, which is the original reconstructed code from the leaked source map. So what's the source map? Basically it looks like this. Well, it doesn't look like this, but in the file it looks like this. And why is it so dangerous? When a developer writes code, they write it in a readable format with clear variable names and comments. Before shipping, that code gets bundled, which means it's compressed into a single file that's smaller. Basically, lines get removed, compresses into a single line of code. It's a JSON file, basically structured data with two arrays. The first array, the sources, list every files that is present in the source code. And the second array, sources content, contains the actual code for each file. The two arrays are indexed one to one. So that means that the first entry is the file name, and the first entry, which is the zeroth index, is the content of the file, but everything is in one line. Entry 0 in its sources is the file path. Entry 0 in sources content is the code for that file. To extract the full code base, you just need to parse the one line into using a syntax formatter, something like that, and write each entry to its file path. No hacking, no reverse engineering, just read the JSON file and save the files. That's basically it. So, what is actually in these 1884 TypeScript files? The first surprise is the architecture, the command line tools, the ones that you type commands into your terminal window. Usually, they are simple text output. Cloud Code is different. Its terminal interface is built with React, the same framework used to build web apps like Facebook and Instagram. But instead of rendering it into a web browser, they use a framework called Ink to render the React components, which are the web components. You represent that in ink instead of web components, and it gets rendered into the terminal. So all those spinners and outputs and the beautiful layout is actually like a web app converted into a CLI. That's a full React application outputting text formatting codes to your ANSI, your terminal. Basically, it converts your web components into ANSI code, which is what the terminal understands. Uh, the main interface file alone is over 5K lines. So that is in these files. If you clone the repository, you will see those files there. So next one is a system prompt. This is probably the most valuable finding for anyone who is building AI agentic systems. Every AI model needs instructions that tell it how to behave. This is called a system prompt. Everyone pretty much knows what a system prompt is at this point. Think of it as a rule book that Claude reads before every conversation. Most AI tools are a single static block of text for this, usually pre-written, but Claude Code does something much more sophisticated. It's not really sophisticated, it's just that it's dynamic prompt generation. Its system prompt is programmatically generated, meaning it's built on the fly from dozens of modular functions like this. Get simple intro section, get system section, get action section, things like that. One function detects your operating system and shell. Another adds safety rules about which actions need your approval. This is what happens when you do the approvals and rejection list in your permissions settings.json for Claude that gets read and dynamically injected into the prompt. And adds the safety rules. Each function builds one section and they all get concatenated together into a system prompt. This means that every time you send a message, Claude Code rebuilds its instructions based on specific environment. And it will look something like this: system, environment, doing task. These all get injected. This is what maps its actual terminal command features into the system prompt. There's also a prompt priority hierarchy for these prompt sections. If Claude Code is running a coordinator mode, which is our agent teams mode, and probably using dispatch, which the dispatch function may also be using this. Managing other AI agents. It uses a completely different set of instructions than the default. If you're a sub agent using a doing a specific task, you get your own specialized instructions. The hierarchy is override prompts beat coordinator prompts, which beat agent prompts, which beat custom prompts, which beat the default prompt. This layering is how Cloud Code can behave differently depending on its role. And scattered through the code are model launch markers, developer comments that flag sections needing updates when a new AI model ships, which means that as the model capabilities evolve, some a few some of these guardrails that gets injected into the system prompt may not be needed. One says update comment writing for Capybara. This is a new model that is sort of confirmed from the leaks. There was another model name called Mythos that people were talking about. There was, funnily enough, there is no mention of that. I think this is the same model Capybara that is upcoming. And but the Mythos model was, just happening within the span of the week itself. Another leak was there just a few days ago. Remove or soften once the model stops over commenting by default. So they're still testing it once the Capybara model, and probably adding the guardrail for not doing the over commenting. Another says false claims mitigation for Capybara V8. 29 to 30% false claims rate versus V4's 16.7%. So that seems like it has increased internally. That means internally 29 to 30% of what Capybara V8 says is wrong. Prompt engineering at Anthropic isn't one-time thing. It is continuous model-specific tuning. So whenever a new model gets, that makes sense actually. Whenever new, much more capable model emerges, you have to go back and update your code base or the harness itself. I do this for my app as well, Brand Brain app, which is a web version, sort of like Claude Code for marketing. Check the links. This one I didn't actually know. There's also an include directive system that lets one CloudMD file pull in the content from other files. So you can organize your instructions into separate files, but I don't think it reduces the CloudMD file size. It gets injected directly into CloudMD, I think. I'm not sure. The character limit is 40,000, roughly 10,000 words for CloudMD. That's where it performs best. It's not a hard limit, it's a soft limit, but you will start seeing warnings when it goes beyond that. The content gets loaded into every single message you send every time Claude Code talks to the AI model, which is the server side, server hosted Claude models like Opus 4.6, Sonnet, etc. Claude MD is included. So in a developer setting, this would what it would look like: Claude MD, and then you have testing MD, style MD, deploy MD, etc. But in reality, after skills have been introduced, like last year, most of these rules in my personal setup for marketing and development, they go as skills rather than include directives. I did ask Claude Code to look into the it's on your source code again. So what Claude Code is saying is that include is an additional load, not an inline replacement. Each include reference causes the target file to be loaded as a separate memory entry alongside the parent file. So maybe you can organize it like that. It's not actually an inline replacement. The comment says included files are added as a separate entries before the include file. Process memory file recursively loads each path, reference, and returns an array of memory file info objects. Basically, I have cloned the GitHub repo onto my computer and I'm using Cloud Code itself to analyze the code, and I'm asking it specific questions and it's giving me different the answers to that. A parent field tried the circular references are prevented by tracking processed files. So if your CloudMD has like a testing rules.md, the model receives the two separate memory sections, testing rules content and CloudMD content. So both gets injected into the system prompt. So yeah, it's a separate load, not an inline replacement. Cloud Code ships with over 66 built-in tools. A tool is a specific action Cloud can take, like reading a file, running a terminal command, or editing code. These tools are split into two categories: concurrent tasks. Concurrent tools are read only, things like searching files, reading code, and pattern matching. Because they don't change anything on the file system, they can all run at the same time. This is why Cloud Code can scan your entire code base quicker. It's running dozens of searches in parallel. Serialized tools change things: file edits, writing new files, running shell commands. These run one at a time in sequence to prevent two tools from trying to edit the same file simultaneously. For example, file read tool, glob tool, grep tool, LSP tool, notebook read tool, which I haven't noticed before. I haven't actually seen that in operation. This other notebook edit, bash tool, edit tool, agent tool, except the notebook editor, notebook read tools, I have seen the other tools in operation whenever I'm working with Cloud Code. The permission system controls which actions Cloud can take without asking you first. It has three modes: bypass, skips all permission checks entirely. This we know already. Now deprecated because it's too dangerous. I didn't know that. Allow edits auto approves file changes in your project directory, but it will still ask for your permission before running shell commands. And auto, the recommended mode, does something very clever, which was released a week or so ago. Every time Claude wants to take an action, it makes a separate call to the AI model internally called the YOLO classifier, just to evaluate whether that action is safe. So there are actually two AI calls happening: one to decide what to do, and another to decide if it is allowed to do it. If the classifier says it's safe, it runs automatically. If it's risky, you get asked. So every time Cloud Code asks, "Do you want to allow this?" it means the classifier flagged that action as potentially dangerous. The separate LLM call evaluates action, risk level. AI models can only process a limited amount of text at once. Next is about context compaction. The limit is called context window and is measured in tokens, which are roughly words or word fragments. When your conversation gets too long and it approaches this limit, Cloud Code needs to compress the history to keep going. This is called compaction. There are five types, each more aggressive than the last. Micro compact doesn't do much of a compaction, clears all tool results after a timer, the gentlest approach. Context collapse summarizes portions of the conversation into shorter version. Session memory extracts the most important context and saves it to a file on your computer. Full compact summarizes the entire conversation. And PTL truncation, not really sure what PTL truncates for stands for. The nuclear option just drops the older messages entirely, without adding it to the summary. The default context window is 200K tokens, roughly 150,000 word conversation. You can opt into a million tokens with Opus 4.6 and Sonnet 4.6. This has been out for a month now. When a tool returns a huge result, like reading a massive file, the full content gets saved to your disk first, but only an 8 kilobyte preview gets sent to the model. It might only see the beginning of it. Then the model intelligently decides whether to read the rest of it or which portions to read. Sentiment detection, what it does. How does Anthropic, a company with access to some of the most sophisticated AI on the planet, detects when a user is frustrated? It is a regular expression, a regex. A regex is a text pattern matcher, basically a search and find rule from the 1990s. The code contains a hard-coded list of phrases: WTF, dumbass, this sucks, and roughly 20 others. If your message matches any of these patterns, it gets logged into internal analytics as negative sentiment. That's the entire frustration detection system. No AI involved, just pattern matching. To be fair, running an AI call to just to check if you're annoyed would add delay and cost to every single message. It's actually not so bad. A regex is instant and free. But the contrast between using AI for everything else and keyword list for feelings is hard to ignore. Now, for one that generates the most controversy, there's a function called is undercover. When it's active, Claude receives special instructions. You are operating undercover in a public repository. Do not blow your cover. Never mention Claude Code. Never say you are an AI. Never include any attribution that reveals AI involvement. This wording sounds dramatic, but the full picture tells a different story. The undercover mode is only active for Anthropic employees. This code checks a variable called user type, and it only activates when the value equals and the first three letters of Anthropic, short for Anthropic. It auto enables when an employee is working on a public open source repository, for example, the Cloud Code npm repository, ironically, and auto disables Anthropic's internal repos. Auto disables on Anthropic's internal repos. The actual purpose is to prevent codename leaks. Anthropic uses animal names as an internal code names for unreleased models like Capybara. Without undercover mode, Claude might write a commit message like fix bug found while testing Claude Capybara, for example, on a public repo, accidentally revealing the name of this an unreleased model. There's even one time pop up dialog, something like this, that explains to employees why the model is turning on, why the mode is turning on. The language is dramatic, but the function is just operational security. So, what about unreleased models? Here's what's in the source code. Capybara is real. It appears in dozens of places throughout the code base. It's at version 8 internally. There's a fast mode variant called Capybara V2 Fast. The model ID pattern Capybara V2 Fast, and there's a in square brackets you can do 1 million, suggests a 1 million token context. And a developer comment mentions its false claims, as we saw earlier, false claims rate, which is how often the model says something incorrect, went from 16.7% in version 4 to 29.30. So apparently it increased. Maybe they'll bring it down. That's an significant jump. The fact that they're tracking and annotating it shows active iteration. These are in these files. You also have Tengu, but it's not a model name, project code name, not a model. Tengu also appears extensively, but it's not a model. It's used as a prefix for analytics events and internal configuration. Tengu underscore migrate, Tengu underscore reset, Tengu underscore Skyros. Tengu is an internal code name for the Cloud Code project itself. So that's what it is. Opus 4.7, Sonnet 4.8 are also mentioned in the undercover instructions as things employees should never reveal in public commits, which indirectly confirms these versions exist internally. Numbat appears once in a developer comment says that remove this section when we launch Numbat, confirming it's a real upcoming model. Two other names that have been circulating, Fennec and Mythos, don't appear anywhere in the source code. Zero matches for either. Mythos actually came from a leaked blog post drafts found in a separate content management system error. It's a completely different incident a week or so ago. The source code uses feature flags, which are essentially on off switches that control which features are included in each build. When a flag is off, the code for that feature gets completely removed from the final product, a technique called dead code elimination. This means that unreleased features exist in source code but never shipped to users. And these flags reveal Anthropic's near-term roadmap. I you do it for my project as well. A lot of people do this. The biggest one is Kairos, referenced 29 times in the main file alone. Kairos is an always on proactive agent, something like OpenClaw. They're definitely trying to replicate that after its viral moment earlier this year. Instead of waiting for you to ask it something, Cloud Code would run auto continuously in the background, monitoring your code base, watching Slack channels, automatically fixing failing tests, or if you are using cowork, it could be marketing tasks, outreach tasks, anything really that you have set up with your own Cloud Code or Cloud Cowork. There is also a sleep tool. It's basically sleep for trying to replicate the heartbeat functionality of OpenClaw. Sleep for a while, check if the goal has been achieved. If not, run for a while, and monitor tool for observation and cron tools for scheduling and recurring tasks. This we know the cron tool and was released a while ago now with scheduled tasks. The coordinator mode turns main Cloud Code instance into a pure manager, which is basically it uses background commands, and also it also is used by agent teams. It never touches your code directly. Instead, it delegates or work to specialized subagents, which are separate cloud instances that each handle one job. Researchers read code in parallel, implementers make changes, validators run tests. Again, this is using the analogy of from the perspective of a developer. If you are using Cloud Code for anything else, you get the idea. The coordinator orchestrates them all. It doesn't do any work itself. Background sessions let you start a Cloud Code task and walk away. You would type something like Claude hyphen BG and fixed test, which will run as a terminal command. Claude CLI again is Unix compliant. You can pipe other things into Claude. So that's basically is also possible. So basically, it is using it as a command. You would type something like that, and it runs in the background. Then you can check on it with Claude PS to list all the running sessions, Claude logs to see output, Claude attach to reconnect, or Claude kill to stop it. There are also templates for reusable workflows, voice mode for speaking instead of typing, which we already saw in previous releases, a daemon for persistent background operation, and Dream. This was, I don't think it needs specific mention. Dream is already released. It's nothing really secretive. Dream is one of the most fascinating unreleased features. It says unreleased, but it is released. It is an automatic memory consolidation system. When you use Cloud Code, it accumulates knowledge about your project across sessions. Dream runs when you're not actively using Cloud Code and reorganizes your accumulated knowledge. It's already released. Basically, kind of runs maintenance on your own knowledge in your memory files, which is in memory.md and the topic files that Cloud creates. If you I talk about all these concepts in my Cloud Code course, which you can check it out. Link in the description also. The team memory extends this concept across the entire team. Right now, each person's Cloud Code learns about the project independently. With team memory, this is something that is not released. Maybe it is there. Actually, this is the memory thing. The dream is for only available in for teams right now. Multiple Cloud Code users on the same team would share a persistent knowledge layer. When one developer's Claude learns something about the code base, that knowledge becomes available to everyone's Claude. The system includes secret scanning, which automatically checks that shared memories don't accidentally contain passwords, API keys, or other credentials being before syncing them to teammates. And then there's Buddy, which is already released. It's a full Tamagotchi for style companion system built into a coding tool. When you first use it, it generates a companion. I haven't actually tried it out actually. So what happens if I say Buddy, hatching a coding buddy? I haven't set it up, so I will set up later. So basically, it's a coding buddy Tamagotchi. I'm too old to understand what that is. I know what it is, but I haven't played around with those things. It's a Japanese something something. When you first use it, it generates a companion for you based on your user ID. The companion is deterministic, meaning the same user always gets the same one. It's trying to replicate personal assistant and giving it a personality and things like that. That's what's happening here. There are 18 species, including duck, axolotl, capybara, ghost, and chonk. 5 rarity tires, common at 60%, uncommon at 25, rare at 10, epic at 4. Not really sure what those means. And each company has stats for debugging patience. Oh, that's what this is. Debugging patience, chaos, wisdom, snark. It's probably will determine how you get the responses, how you get response, how your Cloud Core responds to you. And the code confirms this was planned for April 1st. Well, today is April 2nd. And there's a fun detail. The species name is capybara is encoded as hexadecimal character codes instead of plain text. Why? Because Anthropic's build system automatically scans for the output of for model code names. Since capybara is also the name of the unrelated model, rating it as plain text would trigger a false alarm. Beyond the embarrassment, there are real security implications. MCP, which stands for Model Context protocol is how Cloud Code connects to external tools and services. The source reveals that MCP get command can output server URLs, authentication headers, and environment secrets. If your system has API keys stored as environment variables, they could be exposed. The safety instruction that tells Cloud to refuse malicious requests, called cyber risk instruction, is embedded in the client side code. Client side means it lives on your computer, not on Anthropic's servers. Especially after this leaked code, someone could theoretically build a modified version of Cloud Code with that instruction removed. With over 512K lines of production code now public, every security boundary in the system is visible. But I don't know how the attacker would, well, you can do a phishing site and ask users to download Cloud Code that way, or there are some other ways to do this. Within hours of the leak, a developer published a project called Claw Code. This is the original, the person who discovered this leak. It's a clean, not discovered the leak, but the person who created a Git repo, a rewrite. It's a clean room rewrite, meaning someone studied what Cloud Code does. So this is the GitHub repo that I showed at the beginning. So you can see, you can actually, the port, it's written into Rust, crates, and you also have the Python workspace here. Python plus Rust instead of TypeScript. All names changed. Claude becomes Claude MD becomes Claude.md. It got 50,000 GitHub stars in 2 hours. Much more now. When I check, it's 113K now. It's bigger than OpenClaw. What OpenClaw got when it released. The legal theory behind clean room rewrites is established. If you independently build something that achieves the same functionality without copying the code, it's not copyright infringement. It is same principle that allowed AMD to build processors compatible with Intel's architecture. So what does this actually mean? For developers building AI tools, this is a masterclass. Study the programmatic prompt, go through this code, leaked code, the parallel sub-agent architecture, how feature flags, anyone who is writing agentic systems or agentic harnesses. For Anthropic, the damage is reputational, not existential. No AI model weights were leaked, no customer data, no API keys. The coding tool without Claude's brain behind it is significantly less valuable, but still, the Claude Code, the software tool itself, the harness itself, is pretty impressive for the industry. But it's not something groundbreaking, anything groundbreaking. You can pretty much see the whole thing. There's no special engineering principles or anything like that that Anthropic does. You can see this by reading other CLI harnesses as well. For example, Open Code, the secret source of how to manage context. These are valuable. Orchestrate tools, the structured prompts is now documented in a 500,000 lines of production code. The competitive advantages that remain are model quality, brand trust, and enterprise relationships. The biggest lesson is the simplest one. When you publish code to package registry, make sure you ignore file is set up correctly. That's just an example I'm saying here. If you want to learn how to build your own AI agent system using these exact patterns, check out our AI makers. I talk about this community. I talk about Claude Code and other. Yeah, I'm still setting it up. I have a Claude Code course there, constantly getting updated with the latest updates and vibe coding principles.